This video covers the testing of the 9F Loco and Tender together, before taking them out to the test track. So far the Loco and Tender had only been tested separately. The room in which they were worked on was too small to arrange them one behind the other as they would be on the track. However, I was able to arrange them side by side, as shown in this photo. So that the wheels could turn, I jacked up the Loco back and front and put the Tender on its rolling road units. I then made a long interconnecting cable so I was able to drive the two units via the hand controller. Power came from the 12 volt 38 amp servo power supply. To my embarrassment, when driving the Tender forward, I discovered the Loco was going backwards. Luckily I was able to correct this by reversing the connections in the interconnecting cable. Correcting the drawings took a little longer. This clip shows both units running successfully in reverse from the hand controller. The next step was to check out the sound unit operating via the cable in the Loco boiler. However, I'd introduced some modifications to the sound system which I'll describe first. I decided that the 741 op-amp mixer stage was an unnecessary complication, and that a simple passive mixer at the input to the digital amplifier was all that was needed. To avoid having to modify the circuit board, I simply unplugged the 741 and plugged in a header with pin 2, the summing junction, strapped across to pin 6, which is the output. This worked okay, but volume was slightly down. However, it was easy to increase the MP3 signal. Originally I took the signal from the headphone connector. All that was necessary was to transfer it to one of the push-pull loudspeaker outputs. This had the advantage that I could set the maximum output with the onboard volume potentiometer. This arrangement worked well, and the higher output also gave better signal-to-noise ratio for the long path from the hand controller via the Tender and the Loco to the sound unit. Increasing the maximum chuff volume was also easy. I just changed the output amplifier 22K feedback resistor to 68K. This increased the stage gain by just over 300%. This clip shows the Tender and Loco running with the demand coming from the hand controller, with the synchronized chuff coming from the Loco funnel. The MP3 sounds are then added. My Tender batteries had long since died, so I decided to modify the truck seating to allow an available car battery to be used. Finally, I decided to make up an arrangement to monitor the pull that the Loco would make when on the track. For this purpose, I bought the luggage scale shown in the photo. This unit has had very good reviews for accuracy and cost less than £5. In part 3C I showed the Loco chassis running under radio control. However, that was with a different motor drive amplifier, not the Uni 8 in the Tender. The radio control is very convenient for testing, so I decided to make a special unit that could be plugged into the Tender instead of the hand controller. To keep things simple, I left the forward reverse operated by a toggle switch. The chuff signal could still operate, but not the MP3 signals, since they come from the hand controller. This photo shows the radio control board that I designed. Plus 15 volts comes from the control board Traco DC to DC converter via the hand controller connector at the back of the Tender. It then passes to a 7805 voltage regulator to provide plus 5 volts for the FlySky FS IA6 radio control receiver. This is a sophisticated device that uses the frequency hopping technique patented by the actress Hedy Lamarr in World War II. It also provides a fail-safe facility that brings the demand to zero if the transmitter signal is lost. The pulse width modulated output goes to an eBay PT01A card. This is an extremely versatile device that can be set up to give a 0 to 5 volt output demand signal. The 9F demand signal is 0 to 10 volts, so I added an SGS Thompson rail-to-rail op-amp. This is powered by the plus 15 volts, and by means of a link can be set to give 0 to 10 volts or 0 to 5 volts for a full speed range or half speed range. This photo shows the circuit diagram. The modular construction with interconnecting leads and isolating links enabled me to test the sections individually. I made use of a small servo and an eBay servo tester for this purpose. For the first tests, I powered the card from a small modified Poundland power bank. These units tend to self-discharge through their charging circuit, so in this unit I'd removed one of the two batteries and fitted an on-off switch. Like this, it keeps its charge for months. This clip shows the demand operating over the 0 to 10 volt range. An analog meter is much better than a digital multimeter for this purpose, since it's not always jittering or changing range. This clip shows the system operating under radio control and the effect of the transmitter being turned off. When turned back on again, the demand must be reduced to 0 before advancing. Since I'd not used my test track for some time, I decided that given the sunny weather it would be a good time to take my high-tech survey vehicle and check the running. However, looking along the track I could see that some maintenance would be required. As you can see, it was far from smooth running and gave a new meaning to leaves on the line. However, I felt that once the track was cleared, I would be ready to test the full system. The next part will show the locomotive and the tender running on the track.